Given the head of a linked list, remove the nth node from the end of the list and return its head. So we're given the head of a linked list and want to remove the nth node from the end of the linked list. So this would be the last node in the list. This would be the second to last node in the list. And this is the one we want to remove. Now the way we can remove it is by simply having the node before it point to the node after it. And therefore, it is then removed from our list. So this would get crossed out, and our 3 would then point to 5, the 5 node. Okay, great. So let's go ahead and solve this linked list when n is equal to 5. Let's remove the 5th element from the end of the list. First thing we'll do is we'll find this element. So 1, 2, 3, 4, 5. Okay, so we found our element. But this is interesting, right? Because the way to remove a node from a linked list is to not point to it anymore from the node behind it. But since this is our head node, what can we do? Well, what we can do is we can create a node before it, and we can call it our dummy node. We'll give it a value of 0. It could have a value of anything. And we will have it point to our head node. Okay, so we'll keep this down here. We've got a dummy node. So our dummy node points to 1, which then points to 2, and so on and so forth through the linked list. Now, when we want to remove the 5th element from the end of the list, which is 1, we can point from our dummy node to the next element in the linked list, right? And we want to return the new head of the linked list, which really means we want to return the first node in the list that gives us the list with the nth node removed from it. So this node gets removed. We don't want to return this dummy value, right? So how exactly can we return this value? All we want to do is return this value here, this node. We can call dummy node.next. And we'll see how that works in code in a little bit, but that's how we would return this node. Okay. I just want to point out down here, it says output is 1, 2, 3, 5, as if it's an array. That's not true. What we want to return is the first node in the list. So that's how we remove an element from our linked list. But how do we find that element? How do we find that element? We were able to count down, right? We said 1, 2, 3, 4, 5. But how could we do that in code? Okay, so what we'll do is we'll use 2 pointers to figure out the nth node from the end of the list. Here we've got L, and here we've got R. So these will be our 2 pointers. And we will initially, the first thing we do after given a list, so we've been given this node, right? That is the head of our linked list. That's what we're given in our input. The first thing we do is we create this dummy node, and then we set its value. Then we set its next value equal to 1, so it points to 1, right? After that, we want to set our left and right values equal to this dummy node. And then what we'll do is we will traverse or increment our right pointer by n plus 1. We will increment it or traverse it by n plus 1 times. Okay, so here we go. Here's 1, here's 2, 3, 4, 5, and 6. And right now we have our right pointer equaling null, which is ultimately what our last element in our linked list will point to. So R is at null, and L is still at our dummy node. We can think of it as 0. So what we want to do is maintain the integrity of this distance and traverse both the left and the right pointer at the same rate until our right pointer is equal to null. But since our right pointer is already equal to null, we won't do any further traversing of our left and right pointers. Instead, what we'll do, since our right pointer is equal to null, is we will change where our dummy node points to. So we will have our dummy node point to the place that our head pointed to. And then we will return dummy.node.next, which will be the first value, the head, the new head of our linked list. Okay, so what if n wasn't equal to 5? Let's say n is equal to 2. Okay, so n is equal to 2. We're given our linked list. The first thing we do is we create our dummy node, then we have it point to the head of our linked list. And then we set our left, and our right pointers at the dummy node. And we want to increment or traverse our n plus 1 times. So in this case, 3 times. Let's do it. 1, 2, 3. Okay. Now we want to maintain the integrity of this length, the integrity of the gap between L and R, meaning we don't want the amount of nodes between L and R to change. And we want to increment them at the same rate. The reason we're doing this is because this is how we find the nth node from the end of the list. Eventually, L will end up at the node directly before our nth node. And this is exactly where we want L to be, so we can change its pointer to be on the other side, so that we can change its pointer to point to the node after our nth node. Okay, so let's traverse our left and right pointers. First, we check, is R equal to null? No? Okay, so let's traverse L and R by 1. Is R equal to null now? Nope. So we again traverse both L and R by 1. How about now? No, R is still equal to a node, so we traverse L and R by 1. And there we go. Is R equal to null? Yes, it is, which is exactly how we can tell where we want our left pointer to be. So once R is equal to null, we want to reset the pointer of our left node. At the moment, left points to 4 and 4 points to 5. So what we want to do is we want to set left's pointer to say point to the place where 4 points to, which is 5. Once we do that, we end up with a linked list that looks something like this. So this is exactly what we want, minus our dummy node. So we can return, again, we can return dummy node dot next. That returns the head of our linked list, and therefore we solved this problem. So let's take a look at the space-time complexity of this problem. Well, the space complexity is actually very good. We have 3 pointers here, all of constant space, meaning they don't grow as n increases in size, meaning the allocation they take up in memory doesn't grow as our linked list becomes longer. So therefore, we have a space complexity of O of 1. And for our time complexity, we are looping through or traversing through every element until R gets to null. So therefore, we have a time complexity of O of n. And that's it. So now let's jump into the code editor and solve this in both JavaScript and Python. So the first thing we're going to want to do is set our dummy node and our L and R pointers, or our left and right pointers, as we'll call them here. So dummy node equals new list node. We're calling this list node because that is what this function is called up here. that creates new nodes for this singly linked list. So list node, and we're going to pass in an arbitrary value. We'll pass in 0, and then we will pass in the next, or the pointer, the next node in the linked list. So we're going to pass in head because we want to have this pointer point to the head in our linked list. Then we'll create our left and right pointers. Let left equal dummy node, and let right equal dummy node. There we go. Now what we want to do is we want to increment or traverse right n+1 times. And we can do that using a for loop. So let I equal 0, well I is less than or equal to n I++. So this is going to allow us to move our right pointer. So right equals right dot next. We're moving our right pointer n+1 times, right? Because we're starting at 0 and then we're doing 0, 1, 2 if n were to be 2. And 0, 1, 2 is 3 iterations, therefore it is n+1. Beautiful. All right, so now right is in position and it's ready to start moving left along with it at the same time. So we want to keep the same, we want to maintain the same gap between right and left as we increment or traverse both until right equals a null value. So we can say while right is truthy, meaning like this means while right exists or while right is a truthy value, we want to increment left by 1, so left equals left dot next, and then right equals right dot next. Okay, beautiful. At this point, right is equal to null, and left is equal to the node that's in the perfect position. In this case, it would be 3. In this example 1 here, left is in the perfect position to take out our nth node from the end of the list. So what we'll do is we will set left dot next, so our left pointer, and we will set it equal to left dot next to the nodes, to the node it points to's next node. So we are basically taking this arrow and we are resetting it from pointing to the next node of 4 to pointing to the next node of 5, to the node that the next node it currently points to. And there we go. So that is it. Left did its job. It took out the enemy, so to speak, in red here. And now what we'll do is we will return the head of the list. And now we don't want to just return head, right? Because what if the head here was the one that we wanted to remove? Then our dummy node would point to 2, which would be the proper head that we want to return. So because of such a case, we want to return dummy node dot next, and that will always give us the appropriate or the correct head of the linked list. And there we go. So this is the code, and let's go ahead and submit this. Let's go ahead and solve this in Python. So the first thing we want to do is we want to set our dummy node and our left and right pointers, which we refer to on the blackboard as our L and R pointers. So dummy node equals a new list node, and we're going to pass in a value of 0 and a next of head. So pointing to the next value in the linked list, and we're pointing to the head. Okay. After that, we set left equal to dummy node, and we set right equal to dummy node. Great. After that, we want to increment or traverse right n+1 times down the linked list. So we can open up a for loop for that. For I in range of n plus 1. And this is the first step in the sequence of setting up L to remove the nth node from the end of the linked list. So what we'll do is we'll just set right equal to right dot next to move it down the list. And it'll do that n plus 1 times. And once right is in that position, then we want to increment both left and right while maintaining the integrity of the gap, maintaining the size of the gap between left and right. So, and we want to continue incrementing them until right equals null. So until right is over here. And so what we'll do is we'll just have a while loop that says while right. And that means while right is a truthy value, aka while right is not null. And we want to increment both left or traverse both left and right. So our left and right pointers. Left equals left dot next. Right equals right dot next. Okay, there we go. Now, at this point, right is going to be over here and left is going to be right here in the perfect position to take out this element. And when I say take out, I mean we are going to set left dot next. So we're going to set the pointer of left equal to left dot next. So the same place, the same node, but then we're going to say dot next again. So we're going to point to the node that our nth node from the end of the list points to. We're going to skip over it and point to the next node. Okay, so once we do that, we can return dummy node dot next. And the reason we return dummy node dot next instead of, say, head is because dummy node dot next will always return the proper head, the correct head. Let's say that we had n equal 5 if in example 1 here. So if n equaled 5, our 1 would be red. If we returned 1, it would be the wrong head, as 1 was supposed to be removed from the linked list. But our dummy node, which is in front or to the left of 1, will have skipped over 1 using this left.next tactic, and it would be pointing at 2. So dummy node.next will always give back the correct head of the linked list. All right, so let's go ahead and submit that. There we go. So that is how you remove the nth node from the end of the list in both JavaScript and Python.